Hello and welcome everyone. My name is Henrik Hintze and I am an equity research analyst here at ABG. With me now I have the CEO of Freemelt, Daniel Idlund, here to answer some questions about the company. Glad to have you here.
Thanks, Henrik.
I thought we'd start off with talking a bit about some of the news flow this year. You've announced quite a few development orders and partnerships that you've entered and the like. Could you just give us a summary of the most important milestones in regard to these and how these projects are going right now?
Sure. I mean, Freemelt, we are a small company, and we have big ambitions and global ambitions. Why collaboration is really crucial for us. I would say it's four rationales or milestones that we're aiming for. The first one is to further accelerate the technology development of EPBF technology, so the type of machines that we are using. The other part is about process development. So we work with materials, and those processes is crucial, of course, to get the machine to work and to be able to produce the parts. Here we work with three materials. We work with titanium, with copper, and with tungsten. And tungsten and titanium we have worked for several years, and we of course would like to further accelerate the development of these ones, but also to add new materials as well. The third area is about application development. So everything we do, in the end, we would like to have products that can be serial produced, and for that you need to identify and also develop those applications. You need to help the industry to identify this. So that's the third reason. And then the fourth part is also then to really get access to potential industrial customers. So if I would just update you on a few that we have announced before. So
Yeah.
A&M Texas, we started this project earlier this year. This is a 2-year project. It's with titanium and tungsten process development, so that's a key focus. The end user, or the one that is funding this, is US Air Force. The other one is a Swedish one. This is together with Mid Sweden University and Sandvik. And this is also about process development. This is about tungsten. And to print the part, actually the biggest cost is the powder cost. And Sandvik, they have a chemical reduced powder, which means that you can also substantially reduce the cost for that powder as well. So what Mid Sweden University is going to do is to develop a process so we can use that powder for printing tungsten parts. Then we have one of the recent ones that we announced was Georgia Tech 4.0 Consortium. That's also that's actually a new material. It's within their refractory metals. I'm not allowed to say which material, but so it's actually to define the process to manufacture parts for that refractory, and it's U.S. government that is sponsoring this as well. And then we do other collaborations with our customers, our university customers in Europe, for new materials, and also to improve processes for existing. And just recently we finished the first feasibility study for ultra pure copper. So this is also a key milestone for us now to add that to our portfolio together with titanium and tungsten. We'll then move into two more, which is more than on the industrial side. So WeAreAM, which is our first eMELT customer in Italy. So they are exposed to the Italian industry, and they will develop then applications for Italian metal manufacturing. And then a similar one, but then in the Netherlands, so 3D MZ, also an application center, got commitment from the Dutch industry, and here they will have a first seminar now in September to look into more applications.
Yeah. All right, very good. So you started touching a bit on the eMelt ID there. I was just wondering, you delivered the first eMelt ID this year. Could you just tell us a bit how that has gone and how the customer has reacted to the delivery?
Sure. I would take a step back. I mean, I think first of all, I think it's quite unique that you're able to develop a machine and also install a machine within 9 months. It's quite, it's deep tech, it's physics and quite advanced technology. But this the team managed to do because of the fact that we use the same core technology for across our products. So you can say we pretty much had 20 prototypes of the Freemelt 1 out at the market. So this is why we managed to have that fast development. And the installation went well. So in 2 weeks' time, we managed to install it, to do the training to the customer, and to hand over to the customer. So the customer now is starting to use the machine. They're starting now with titanium as the first material, and also do some application development. And actually next week we have our first industrial prospect, so a customer reference that will come and see the machine as well. So which of course is very crucial for us now. We will upsell, or we will sell more thanks to of course customer references. Yeah. I think the feedback from the customer as well. This is an experienced 3D printing customer. They have also used EPBF in the past as well. So I think what they appreciate initially now is the modularity. It's really simple, accessible to work with from an ergonomic perspective. So far so good, I would say.
Very good. All right. So you also have the eMelt IM. Could you just quickly explain the difference there and what we can expect on that front going forward? When will that be ready to make its first sale and delivery?
Sure. As you rightly said, I mean, eMelt IM, that's our serial producing machine. So that there you have 4 build chambers to really have an efficient serial production. The eMelt ID is actually scaled down from IM. So in a nutshell, it's the same machine, but with 1 build chamber. Maybe recap of the process. I mean, as I said, I mean, eMelt IM is really for high volume production. And to establish high volume production, then of course you need to start first to do material process development. You need to develop products that needs to be commercialized, and then you need to create the demand. So I would say the initial ramp up of production, I think our customers will actually use the 1 build chamber, so the ID. And then when they have established more demand in the market, then the IM will be of interest for them. So to answer your question, I think when we can expect the first sales there, I would say maybe second half of 2025.
Yeah. Okay, very good. So you're clearly now in a commercialization stage. You're trying to get machine sales running. You're building a sales organization to power that. Could you just tell us how that is going and what other important steps you're taking to improve machine sales going forward?
Mm-hmm. Yeah, we have been established both the European team, so we have 4 people commercial in Europe, and also in US as well. We have also now added more people there. We have 5 in total in the US. Except for salespeople, one of the key resources to support sales is application engineers. So that's also now what we have added to the team, both in Europe and also in US as well. We have also just recently actually opened an application center. So we have put the machine in one of the advanced manufacturing centers in US that will also then support first to bring customers to that center and to help customers to develop their processes and also applications. And then what we also try to do more now than before is to be more present at industrial trade fairs to show more what we can do in those end applications as well.
Yeah. All right. You've previously expressed an ambition to build a significant aftermarket business with your machines. Could you just tell us, are there early steps you're taking now to enable that going down the line, or is the priority now really more machine sales and aftermarket will come later?
I think the aftermarket part, that will be harvesting when you have a big install base, of course. But we need to, start small. So of course we try to build in the right kind of sensors in the machines from the start now, so we can start to collect the right kind of data, so we can become more preventive and take care of the aftermarket in a better way. From an aftermarket, I mean, if you look into also the design of eMELT, I think the whole machine has been designed from a simplicity point of view, the modularity again. So I would say we have already started to consider this, but business-wise, as I said, I mean, that will come when the fleet is more mature and bigger, yes.
All right, very good. So we've been talking a lot about the interesting prospects you're seeing in defense and energy, but you've also mentioned that medtech is one of your key focus markets, but we haven't talked as much about that recently. Could you just give us an update on what you're seeing there?
Sure. No, I think you're right. I mean, I think our last half year has been a lot of exposure and focus on tungsten and defense and so forth, and energy as well. But actually the most mature application when it comes to additive manufacturing is medtech, and especially orthopedic implants as well. So this is titanium. So the highest adoption rate is in implants. With that said, it's only 5% of all the implants that are produced by additive manufacturing, and the industry expected to grow in the next 7 to 8 years to 20%. So they still expect a lot of growth in that area. This is an application pretty much that the company since it started has been focused on as well. So we have developed a titanium process, which is done now. Now we move more into application development and pretty much also more, I would say, product certification, because this is a highly regulatory industry. So, and we will not do the certification, that our end customers will do. So actually now we are more in, I would call it more in a commercial phase with those potential customers that then may be of interest to start to produce their products with our technology. And I think we should also mention that electron powder bed fusion, which we use, if you look into the current install base globally, actually the biggest exposure in installation is within implants.
All right, very interesting. So in conjunction with the Q2 report that you released recently, you stated that you consider yourself to be ahead on Freemelt's 2030 plan. Could you just give us a brief reminder of what the plan is, and then tell us a bit about what makes you feel that way and how Freemelt is progressing?
Sure. Now we haven't exposed too many details about the plan, but what we have said is that we, by 2030, should be the number one in all tungsten applications suitable for our machine. We should be the number one when it comes to orthopedic implants. And when I say number one, it means that we have a solution for these applications that are the most productive, so with the lowest total cost of ownership. Financially, we have also then stated that we should be a 1 billion SEK company at that time, so a turnover of 1 billion SEK with a 25% share of that revenue coming from aftermarket. I would say if I do an assessment now, I would say tungsten, according to our knowledge, no one can print tungsten in with the quality of the parts, with the productivity that we can. So I think there we've making really good progress. Implants, as I just talked about before, I mean, I think we are getting there as well, but it takes longer time to break through there as well due to the regulatory side as well. Of course, Freemelt ONE, we should also keep that in mind, because Freemelt ONE is a key enabler for a lot of the industrial side as well. And their sales so far has been fairly, I would say, moderate during this year.
Yeah.
And but I think on the other side, what we did not really expect, and I think this is also because of the geopolitical situation that we see around the world now, the number of industrial prospects requesting feasibility studies to actually now start to investigate about the opportunities, mainly in tungsten, has increased more than we expected, which means that the 5 machines that we have in Gothenburg is not enough. So now we need to find partners to collaborate with. I mentioned about the machine that we're now installing in the US as well, to really serve especially the US defense industry. So on that side, I would say we're ahead of the strategy. So all in all, I think we're making good progress according to the plan.
All right. Thank you very much for that, Daniel. That's all we have time for.
Thank you.
Thank you all for watching.